Okay, so this is the solution to the test. So problem number one, I give you a quadratic equation and ask you to find the x and y intercepts, the vertex, and the equation for the axis of symmetry. I gave you guys a break. I didn't grade you on the axis of symmetry because most people didn't do that. So the first thing you have to do is put it in standard form. And yeah, I realize now that I didn't show you one like this. It didn't have this constant in front, but we talked about it in class, and we did homework that had this. So anyway, what you do is if you have a constant in front of the x squared, you factor that out. And you factor it out of both the x squared term and the x term. And then we put the constant by itself. So we're doing completing the square, and if you divide negative 12 by 3, you get negative 4. So if you multiply this back out, you'll get here. So to complete the square, you take the coefficient in front of x, divide by 2, and you square it. So that's negative 2 squared, which is 4. So we add 4, but you can see we're adding 4, but we're really multiplying by 3 as well. So we're adding 12. That means that we subtract 12 to balance that out. And then you can complete the square in the term in the parentheses, which is, it's this number, x minus 2 quantity squared, and add those two together, you get negative 16. So it's in standard form, and so the vertex is going to be equal to 2 comma negative 16, because we have x minus h. So you have a times x minus h squared plus k. So because we have a negative here, h is 2, and k is negative 16. So that's the vertex. To find the y-intercept, you set x equal to 0, so you evaluate the function at 0, which is just going to be negative 4. So you go back to this form to do the y-intercept, and the intercept is a point, so you put the point, which is going to be 0, x equals 0, y equals negative 4. So if you just did that, you got point taken off. Okay, so that's the y-intercept, that's the vertex. The x-intercept, we can take the standard form and set that equal to 0, because what we're trying to do here is figure out the values of x such that the y value is 0. So what we want is, we want some function, something comma 0. What values of x to plug into here and get 0. So we take the standard form, and this is kind of like completing the square in some ways. So we want to solve for x. So you add 16 to both sides. You divide both sides by 3. Now, because this is positive, that means we are going to have real zeros. Now, if you take the square root, you'll get plus or minus the square root of 16 over 3 is equal to x minus 2. If you add 2 to both sides, you'll get 2 plus or minus the square root of 16 over 3, which is 2 plus or minus 4 over the square root of 3, which is 2 plus or minus 4 times the square root of 3 over 3. So if you multiply the numerator, the denominator by the square root of 3, that gets rid of the square root of the denominator. Now if you did this, that's fine. I didn't take anything off to get to this point. So my x-intercepts are ordered pair, and so it's going to be 2 plus 4 times the square root of 3 over 3, comma 0, and 2 minus 4 times the square root of 3 over 3, comma 0. And it turns out the axis of symmetry is an equation. It's x equals 2. So it's just the x value in the vertex. And I didn't ask you to graph it, but if I did graph it, the vertex is going to be 2, -16, so be somewhere down here, and then you have it going up like this, and so this would be my axis of symmetry. This would be x equals 2. This would be my vertex 2, -16, and these 2 points would be sorry, these 2 points would be these 2 points, and then you have a y-intercept, which is right here, which is -4. So this thing would intersect the y-axis right here. So we know that this point has to be over, because the y-intercept is negative. It's going to, if we draw the vertical axis here, the y-axis is going to be just slightly to the left of the origin. Okay. Number 2 says, use long division to solve the equation below. So we could use synthetic division, but that's not what I asked you to do. So because we have some missing terms, you're going to put zeros in there. So there's no x cubed terms, so we're going to put 0x cubed, and we're going to have minus x squared plus 0x plus 11, and we're going to divide that by x plus 3. So the question is, what do I need to multiply x by to get x to the 4th? So the answer is x cubed. X cubed times x is x to the 4th. X cubed times 3 is 3x cubed. Now, most of you did this wrong, and obviously you didn't pay attention to what I was saying, and you got it wrong as a consequence. But when you multiply this out, you get x to the 4th plus 3x squared. But what we're doing is we want to subtract that, because we're trying to eliminate each term as we go through here. So this plus -3 is 0. So you got to make sure you reflect that here, negative sign. So it's going to be 0 plus a minus 3, which is -3x cubed. And then you bring the next term down, -x squared. So what do I need to multiply x by to get -3x cubed? -3x squared. So a lot of you got plus here instead of minus. Okay, so multiply that out. -3x squared times x is -3x cubed, and -3x squared times 3 is going to be -9x squared. But we're subtracting that, and we're subtracting both terms. So -3 plus 3 is 0. -3 plus 9 is plus 8. So we get 8x squared. Bring the next term down, which is 0. So what do I need to multiply x cubed x by to get 8x squared? Plus 8x. So you add plus 8x. So 8x times x is plus 8x squared. And 8x times 3 is plus 24x. But again, we're subtracting both of those terms. So this goes to 0. Here we get -24x. So then we say, well, we bring down the 11, plus 11. So what do we need to multiply x by to get -24x? -24. So -24 times x is -24x. -24 times 3 is -72. But I'm subtracting that. So I'm subtracting because I want to eliminate this term. -24x plus 24x is 0x. Here I have 11 plus 72. 11 plus 72 is 83. So that's the remainder. Now, when I said what is the remainder, what does the value of the remainder equal? Well, yeah, it's equal to 83, but that's not what I was asking for. I was asking for what was the significance of the remainder. And the significance of the remainder is that if you evaluate the function, the original function here, at -3, so you take this, set it equal to 0, solve x equals -3, the f of -3 is going to be 83. So you can use the remainder to know what the value of the function is at whatever corresponds to this, the 0 corresponding to this factor. So that's what I was looking for. I decided not to take off of that, but I did talk about it in the review. Okay, the next one says one of the zeros of the following third order equation is x equals 1. So I ended up taking a lot of points off when you obviously used your calculator to plot it and then tried to figure out how to answer the questions. So the answer, what you're supposed to do, we did it in all the examples in class, was you figure out what the zeros are, then you plot it. You don't plot it and then figure out what the zeros are. And I'm pretty sure I told you in the review that you were not to use your calculator except to do calculations, not to plot stuff. And so since the only way that you could get those answers is to do what I told you not to do, then I was not very sympathetic with what you did. Okay. So back to the question here. So it says one of the zeros is x equals 1. And that means we have a factor of x minus 1. Remember, this is 0, this is the factor. Now, you can use synthetic division in this case because the 0 or the factor is just a linear factor. And you use 1. You use the 0 here. And then you put the coefficients for the different terms in here. And if this is actually a 0, you should end up with a 0 remainder. So if you didn't get a 0 remainder, you should have said, oh, I must have done something wrong. So, okay, so we bring this down 1. 1 times 1 is 1. 6 plus 1 is 7. 1 times 7 is 7. 3 plus 7 is 10. 1 times 10 is 10. You get a 0 remainder, okay? So that means that this is 0. I didn't lie to you. And what I'm left with is x squared plus 7x plus 10. And I said that, unless I told you otherwise, you should be able to factor these. So you're going to have x and x. Well, two numbers multiplied together give you 10. 1 and 10, 2 and 5. Adding both together give you 7. 2 and 5 work out, so it's going to be 2 and 5. And because I have a positive here, they have to be the same sign. And this is positive, so they both have to be positive. So you needed to do the factorization. You need to do the division, end up with the quadratic, do the factorization, and that means the zeros are going to be x equals -2 and x equals -5. So that gives me 3 zeros. X equals 1, x equals -2, and -5. So those are the zeros. I also ask you to find the x-intercepts. These are also the x-intercepts. The zeros. I guess the intercepts would be 1, 0, -2, 0, -5, 0. So those are the intercepts. The y-intercept, you evaluate the function at x equals 0, which is just -10. All these terms go to 0. So that's the y value when you set x equal to 0. The y-intercept is 0, -10. So that's the y-intercept. So now we can get a piece of graph paper. Or at least I can, because you already had one in your tests. You didn't have to get one. Okay, so what we do is we plot all these things that we have. So we plot our intercepts, which are -5, 0, -2, 0, +1. We also know that the value of the function at x equals 0 is negative 10, so that's that point right there. Now we don't know how far this function goes above, so I didn't ask you to do that. I just said, you know, do your best shot here. So it might go all the way up to positive 10. I don't know. I didn't really pay attention to what was going on there as far as how far you took it up. You could have evaluated the function at negative 1, 2, 3.5. Now this y-intercept is not centered, so it probably does go up, may even go up a little higher. So this probably goes something like that. Might even overshoot, and then it goes back down this way. So the end behavior is just this part and this part. So that's what I was looking for. Okay, the next is a rational function. You guys did much better on this one. Not sure, I guess because it's not that hard to solve for the thing. So we have this function, rational function, and so the zeros of the numerator are the x-intercepts, or the x-coordinate of the x-intercept. The zeros of the denominator are the vertical asymptotes. So you can factor the denominator, x minus 6, x plus 1. That's the function. Okay, so first thing, x-intercept. So the x-intercept is when f of x equals 0. We're trying to figure out what the values of x are. So all we have to do is have the numerator go to 0. The denominator plays no part in calculating the x-intercept. So if we solve that, you'll get x is equal to 3/5. So you take this to the other side, divided by 5. So the x-intercept is going to be equal to 3/5, comma 0. The y-intercept that's f of 0. So you plug 0 in, you'll get negative 3 over negative 6, which is positive 1/2. And the coordinate is going to be 0, comma 1/2. So that's my y-intercept. My vertical asymptotes are equations. X equals 6 and x equals negative 1. So they're the values of x where the denominator goes to 0. So, you know, x minus 6 equals 0 gives you x equals 6 as an equation, and x plus 1 equals 0 gives you x minus 1. So those are the equations for the vertical asymptotes. And then your horizontal asymptote, because the order of the numerator is lower than the order of the denominator, it's y equals 0. So you don't use the leading coefficients because this is not squared up here, it's just the first power. So I didn't ask you to plot it, so those are the four things that I asked you to find. Okay, the next one, so this is in the review. If I give you one 0, x equals, if I give you one complex 0, then the other complex 0 is going to be the complex conjugate. So those are the two roots. You have one, I gave you one, you automatically can get the second one. Now the corresponding factors are going to be what I would do if I set this made this equal to 0. So this is going to be x minus 2i equals 0, and this is going to be x plus 2i equals 0. So these are the factors. So what you do is you multiply these two factors together, and you'll get x squared. The inner and outer cancel out. The last is negative 4i squared, which is plus 4. So that's the quadratic part. So then to find the linear part, you're going to use long division again. So we got 1, well, that's not long division. You got x to the 4th plus 4x cubed. You can't use synthetic division because I've got a quadratic term here, and you can only use synthetic division when you have a linear term. So here we have x to the 4th. So again, you guys who don't know how to do long division, you got it wrong. Okay, so the question is, what do I need to multiply x squared by to get x to the fourth? So the answer is x squared. So x squared times x squared is x to the fourth. X squared times 4 is plus 4x squared. But I'm subtracting both of those. Both. Okay. So when you add these two together, or I subtract this from that, I get 0. We'll bring this down, 4x cubed, because there's no term here. So you have this minus 0. Here I have negative 1 minus 4. So you get negative 5x squared. And plus 16x. Now the reason I'm bringing this down is because I have these, just a quadratic term and a linear term, a constant term. So what do I need to multiply x squared by to get 4x cubed? So the answer is 4x. So 4x times x squared is 4x cubed. 4x times 4 is 16x. And I subtract both of these. Not just this one, but that one too. So this goes to 0. 16 minus 16, I get 0 there. And here I just bring it down. And then on the last thing I bring down the negative 20. Okay, so what do I need to multiply x squared by to get negative 5x squared? So the answer is negative 5. Negative 5 times x squared is negative 5x squared. I don't have anything here. And then I've got negative 5 times 4, which is negative 20. Again, I'm subtracting both of these terms. So this goes to 0, and this goes to 0. So I've got a 0 remainder. And it has to work, or I didn't give you the right. When you get a 0 other than a remainder other than 0 here, you'd say, hey, either the teacher did it wrong or I did it wrong. And it, sometimes it does happen, but in this case it didn't. So what I'm left with is x squared plus 4x minus 5. So I should be able, hopefully I'll be able to just factor that. So I'd say, okay, what two numbers multiplied together give me 5? Well, 5 and 1. Now because this is negative, it means one has to be positive and one has to be negative. Now, because I have a plus 4x here, that means that I'm going to put the 5 plus with the 5 and negative with the 1. So you see that works. So my original, so those are my factors. So let's rearrange. So we can say the original equation so that can be rewritten as x. So these two, x minus 2i, x plus 2i, x minus 1, x plus 5. So those are the factors. The actual zeros are x equals 2i. That's if I set that equal to 0 and solve for x. If I do that, I get x equals negative 2i. So if you remember, I gave you 2i. You figured out the other one was negative 2i because it's a complex conjugate. And then the other zeros are going to be 1 and negative 5 because I'm saying x minus 1 equals 0. For that to happen, x has to equal 1 and x plus 5 equals 0. So x equals negative 5. So, two complex, two real. Okay, next one. So all we're doing here is just rewriting in standard form, which means we do not want any complex stuff in the denominator. So to do that, you have to multiply by the complex conjugate of the denominator. Some people just multiplied by the denominator, and that doesn't really help you out a lot. So we do the complex conjugate so that we can make this denominator become real. Okay, so in the numerator we have 3 times 1, then we have plus I, and then we have minus 6i, and then we have minus 2i squared. So negative, positive times negative is negative, 2, and I times I is I squared. And the denominator, we have 1 times 1, which is 1. The inner and outer cancel out. and we're left with negative 4i squared. But remember, I squared equals negative 1, so I can have 3 plus I minus 6i minus 2 times negative 1, and 1 minus 4 times negative 1. So here I've got 3 plus 2, so that's 5. I've got 1 minus 6, which is negative 5, and a divide by 1 plus 4, which is 5. And so you can simplify it down to 1 minus I. So that's the solution. So you're not always able to divide this out. It just turns out in this case you could. Now, the next problem, all I wanted you to do was list the possible rational zeros. So what you do is you look at the factors of the numerator of this equation is the factors of the last term, which is 6. So I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So that's the factors of 6. Actually, the factors of negative 6. Because I could use plus 1 and minus 6, minus 1 plus 6. So that's why I can do both plus or minuses. And the q is the denominator of this expression. We're going to look at p over q. So q is 2. So the factors of q are 1 and 2. And so my possible numbers are plus or minus 1. You could have negative 1 times negative 2. You could have positive 1 times positive 2. That's why you have both. So we have all these choices in the numerator, and we have all these choices in the denominator. So there's 4, 8 because of plus or minus, and then you divide by plus or minus. Well, that doesn't give you any extra because you can either divide by plus or minus. So what we have are basically plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. That's dividing by plus or minus 1. And then you have plus or minus 1 over 2, plus or minus 2 over 2, plus or minus 3 over 2, and plus or minus 6 over 2. So what I've done there is I've got all 4 choices in the numerator and the second choice in the denominator. But this is, we don't have to do that because that's 1. Plus or minus 2 over 2 is 1, and we don't need to do that because 6 divided by 2 is 3. So if we go from most negative to most positive, we've got negative 6, negative 3, negative 2, then we have negative 3 halves, then we have negative 1 half, and then you just do the same thing in the positive direction. Oh, I forgot 1, so sorry. We also have negative 1, and then negative 1 half. And then you can go the other direction with 6, 3, 2, positive 3 halves, positive 1 half. So those are the possible rational zeros. Okay, next to irrational functions again. So here's the function f of x equals x squared plus 4x minus 2 divided by x minus 1. So it says the x-intercepts are not integers, so that means that you're going to have to use either completing the square or the quadratic formula to factor the numerator. But they are real. There are real zeros there. So what I did is I used completing the square, but you could use the quadratic formula if you wanted to. So to factor it, I set equal to 0, and then solve for the values of x where it goes to 0. So again, what you're going to do is you're going to take the negative 2, put it aside here, take your 4, divide by 2, square it. So that's 2 squared, which is 4. So we add 4 here and we subtract 4 there. So we get x squared plus 4x plus 4 equals 6. Then you write the left-hand side as a complete square. So you get x plus 2 squared is equal to 6. Take the square root. X plus 2 equals plus or minus the square root of 6. X equals negative 2 plus or minus the square root of 6. So my zeros, I've got two zeros, and it's going to be negative 2 plus the square root of 6, comma 0, and negative 2 minus the square root of 6, comma 0. So those are my my x-intercepts. So that's by setting the numerator equal to 0. Okay, the next thing, y-intercept. So the y-intercept is you evaluate the function at 0, which is going to be negative 2 over negative 1, which is 2, and the y-intercept is a coordinate, so it's going to be 0, comma 2. So that's your y-intercept. Then we have the vertical asymptote. So the vertical asymptote is an equation, x equals something, and it's the x where the denominator equals 0. So all you do is just set the denominator equal to 0. You get x equals 1. That's a vertical line. And then the horizontal asymptote, well, in this case it was a slant asymptote. And the reason it's a slant is because this is squared and this is just to the first power. So that means that there is no horizontal asymptote. So what you have to do is use long division. I guess you could use synthetic division if you wanted to. So you just divide this out. So you say, what do I need to multiply x squared by to get x squared? Well, the answer is x. So x times x squared is x squared. X times negative 1 is negative x. You subtract both parts. So when you subtract this, here you get 0. And here we have 4. A negative is a positive, so it's going to be 5x there. What do I need to multiply x by to get 5x? The answer is 5. 5 times x is 5x. 5 times negative 1 is negative 5. I'm just going to subtract both of them, and I've got my negative 2 up here, so bring that down. So when I do the subtraction here, I get 0. Here I've got negative 2 plus 5, which is 3. And we really don't care what the remainder is. We just care what we got up here. And so the slant asymptote is an equation. Y equals x plus 5. So that's the slant asymptote. Okay, another one, rational function. F of x equals 3x minus 6 over x minus 1. Okay, so it says plot the following rational function by determining the x-intercept. So the x-intercept is you set the numerator equal to 0, solve for x, so you get x equals 2. The intercept is a ordered pair, 2 comma 0. So you can see if I stick 2 in here, I'll get 3 times 2 is 6, minus 6 is 0, divided by 2 minus 1, which is 1. 0 divided by 1 is 0. Okay, so that's the x-intercept. The y-intercept, that's f of 0, so that's negative 6 over negative 1, which is 6. Again, the y-intercept is a ordered pair, 0 comma 6. The vertical asymptote is you set the denominator equal to 0, and you end up with the same thing in the previous problem. That's a vertical line. Okay, so that represents a line. As far as the horizontal asymptote is concerned, because the two highest order terms, which are x, are the same, you take the ratio of leading coefficients, which is 3 and 1, so you get a line. So the line is y equals 3. Not just horizontal asymptote is not 3. Y equals 3 is the horizontal asymptote. Okay, so let's get a piece of graph paper. So let's plot what we have. We'll plot our x-intercept is 2, 0 right there. Let's go ahead and put some scale on here. Okay, so that's the x-intercept. The y-intercept is 0, 6. That goes right there. I also told you to evaluate the function at 3, so let's go back and do that. So if we evaluate the function at 3, we'll get 3 times 3 minus 6 over 3 minus 1, which is 9 minus 6 over 3 minus 1, which is 3 over 2. So we have this other coordinate pair, which is 3, 3/2. So we're gonna plot that. So we get 1, 2, 3, 3/2, which is 1.5. So that's an additional point. Okay, so we've got the y-intercept, the x-intercept. We've got this additional point. We've got a vertical asymptote at +1, and we've got a horizontal asymptote of 3. So this is y equals 3, this is x equals 1. And so our curve is going to approach this vertical asymptote. So a lot of people drew it going straight down here, but it's supposed to approach this vertical asymptote. So it's going to come up like this, go through this point, then go through this second point, and then it's going to approach this horizontal asymptote like that. And then we have this point over here, so we know that it's going to have to be kind of symmetric around here. We could have plotted some more points to make a better drawing, but that's essentially what it looks like. So again, this curve should approach this vertical asymptote, and this curve should approach this horizontal asymptote. So I was looking for these points, these two things, and then drawing it correctly. Okay. The last 4 problems. Number 10, find the inverse. So went through this procedure. So the first thing you do is you replace f of x with y. Then you switch x and y. Y becomes x, x becomes y. And then you solve for y. So we're going to add 3 to both sides and then divide by 4, and you'll get y is equal to x plus 3 over 4. So that is and then you could say the inverse function in f inverse of x is equal to x plus 3 over 4. So that was your answer. Number 11, it said, prove analytically that the following 2 functions are inverses. A few people took one function and found the inverse and saw that it was the same, which I don't think I took off of that. But what I was looking for was if we call the first function f of x and the second function g of x, and then we take the composite function f of g of x and g of f of x. So what we want to do is f of g of x. So we take the original function, and instead of having x, we plug in g of x. So what will happen, these cancel out. You end up with x plus 1 minus 1, which is x. So that works out. F of g of x should be x. And then the same thing should happen the other direction. G of f of x. So here's our function. So this is the parenthesis, and I'm going to put a parenthesis to put my value in. Plus 1. These two match. Divide by 5. Okay, so what I'm doing is I'm plugging this into there for x. So you get 5x minus 1. So in the numerator I have 5x minus 1 plus 1. So those cancel out. And then you end up with 5x over 5, which is x. So because f of g of x and g of f of x equal x, therefore they're inverses of each other. Okay, that was actually 12. 11, all I was asking to do was to do the multiplication of complex numbers. So these are the two complex numbers. Use FOIL. So 2 times 1 is 2. Outer is 2 times -5, which is -10i. Inner, which is plus 4i. And then last is going to be -20. -5 times 4 is -20. And then you have I squared. Now these go together. -10i plus 4i is -6i. And then you have -20 times I squared. I squared is -1. So you get 2 minus 6i plus 20. Negative times a negative is plus, so you end up with 22 minus 6i. So that's your answer. And the last one, all I was looking for you to do is to just do a synthetic division problem. You didn't have to factor it or anything like that. So I just wanted you to simplify this expression. And you can simplify it if you get a zero remainder. So I use synthetic division. Most everybody uses synthetic division. Actually, I asked you to do synthetic division. The key thing here is that when you do it, you don't use 2, you use the corresponding 0. So if I have x plus 2 equals 0, this corresponding 0 is -2. So you should have used -2 here. And if you use +2, you'll get a remainder, and then you'll say something's wrong. Okay, so bring the 1 down. -2 times 1 is -2. Add these, you get 3. -2 times 3 is -6. Add these two together, you get -8. -2 times -8 is +16. Add those together, you get 0. So that's what I was looking for. And then you'd use the remaining coefficients to rewrite the equation. So what I was looking for, I wasn't just looking for that, I was looking for what is f of x equal to, and it's equal to x squared plus 3x minus 8. Now somebody said, I can't factor that. Well, you could. You can use the quadratic formula, or you could use completing the square. Because this is odd, you might use the quadratic formula. I didn't ask you to do this, but since somebody said they could not figure out how to do it, you'd have minus b plus or minus the square root of b squared minus 4ac divided by 2a. So you get -3 plus or minus the square root of, well, 4 times 8 is 32. It's a -8 there. Okay, -8 times -4 is 32. 32 plus 9 is 41. So you'd get plus the square root of 41 divided by 2. And that's all you can do. So this does have factors. They're just not nice factors. So that's the solution.